Okay, so let's get started. We're going to be taking a look at our ignition timing compensation tables and how they affect our spark timing in our M1 programming. Now, the ignition compensation tables will act as either an adder or a subtractor in our spark timing against our main spark timing table. We're going to find things like air temperature and coolant temperature are the primary things that we need to compensate for and either advance or retard our spark timing from that centralized kind of main spark timing value we're in command at the engine's operation at a given load and engine speed. Let's jump in here from our fuel tuning page and let's move over across here to our ignition tuning page. This is going to house all the information that we need to know and to work with for dialing in our spark timing as well as our compensation tables. Now, in my firmware package, which is going to be the GPRP package, it'll also suit the GPR package, you'll find that the compensations we have in here are going to be firmware limited. If you have a different firmware package, it may have further ignition compensation tables available, but we're going to be kind of covering what the standardized compensation tables will be and what they represent. And then you'll be able to go in and take a look at your firmware package and see if there's something additional in there that you might need to work with or know about for dialing in another type of condition. So let's break this down of what the compensation tables actually represent. If we take a look here in our window, we're going to find that we have our main spark timing table. Now, we talked about this in our last training module, and we actually set up both a naturally aspirated and a forced induction example. We know that we have our spark timing values in the table here are going to be relative to degrees before top dead center on our compression stroke, degrees BTDC. We'll find that this is where we want to fire off our spark plug to initiate that combustion event, and ultimately, if we get our spark timing value in our table here dialed in right, we'll reach maximum brake torque out of our engine. That's where we have the optimized point where the peak pressure from our flame front and from our combustion event is going to push down on the piston on our power stroke at 15 to 20 degrees after top dead center. And that's going to be the most ideal mechanical advantage point to take advantage of the thermal energy and that pressure that the combustion is going to deliver. Now, we're not always going to be able to get maximum brake torque, but that's ultimately the goal we're going to strive for. Now, the make spark timing table is going to represent a couple additional things here. This is going to assume that the engine is in average operating conditions, so anywhere between, let's say, 60 to 80 degrees Fahrenheit air temperature, and then also about 160 to 200 degrees coolant temperature, and the engine will run in these kind of normalized or average type of conditions. So this assumes this is the spark that we're going to deliver to the engine, and the engine's going to be happy there. Now, what happens if we get into extremes? Really cold or really hot air temps, or really cold coolant temp or really hot coolant temps? We'll find that the spark timing will change that we actually need to deliver to the engine to avoid knock or pre-ignition, for example, or to avoid engine damage. So there are definitely some things we need to consider here. So what we'll find is that the spark timing value here is from the main spark timing table is under these kind of average or normalized conditions. Now let's talk about here what we have in terms of our compensation tables and what those represent. What we can find if we take a look down here, we have an intake air spark compensation table. And this table right now hasn't been populated. It's just going to be a singular 1D value. We actually have to turn this into a table that we can start to program and work with. And we can make this table pretty simple and turn it into just a two-dimensional table. If we click on our area right here and click A, we can go in here and turn on the inlet air temperature as our main primary axes and turn it into a two-dimensional table. We can also go in here and turn this on for engine load normalized. Again, engine load normalized can represent a couple different things. That's what's found as our main runtime axes here for load on our ignition timing main table. Engine load normalized can be a function of air mass if we select it that way, and that will be essentially engine load is what the engine load is going to be what the air mass calculation is going to be. Again, we have our underlining equation, fuel mass is equal to air mass divided by our target air fuel. So the option when you select under your setup, under different setup window, we talked about this in a previous training module, engine load normalized can be a function of air mass. If we make changes to the volumetric efficiency table, that affects the engine load calculation, affecting the air mass, and essentially affecting where we track in the table here. That would be more kind of representation of a OEM ECU that's mass airflow based. Now, normally engine load normalized will be represent to the map pressure, so inlet manifold pressure, as we find up here. That's going to be an option we can select. That's the typical option for most standalones you'll find for calibrating and tuning. So this would be a function of your map pressure. It's pretty standardized kind of deal for tuning and dialing in your spark timing. Now, we also can set engine load normalized to throttle position. So this would be between 0 and 100% throttle.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.